Ever wondered how computers and devices communicate? It's all thanks to network devices, which make data travel smoothly from one device to another. Let's explore some of the devices in this video. Hello everyone, I'm Gautami Kota, a 4th year CSM student from Gayatri Vidya Parishad College of Engineering. In this video, we are going to talk about network devices like network interface card, repeater, hub, bridge, switch, router, and gateway. Let's get into the video. The first thing that we're going to discuss today is Network Interface Card. A Network Interface Card or NIC is a hardware component inside a computer that connects it to the network. It operates at the data link layer and the physical layer of the OSI model. Every NIC has a unique MAC address which acts like the identity tag for the device on the network. It can be wired, like using an Ethernet port, or wireless, like a Wi Fi card. When you send or receive data, the NIC converts it into electrical and radio signals that travel through the network medium. You can think of the NIC as your passport to the network. Without it, your computer cannot communicate with the outside world. The next one is repeater. A repeater is a network device that operates at the physical layer of the OSI model. Its main function is to amplify or regenerate weak signals. When a signal travels over a cable, it gradually loses its strength due to noise and distance. The repeater receives that weak signal, cleans it, and retransmits it with the original strength. It does not filter or interpret data. Instead, it just simply regenerates bits. Imagine you're shouting across a long hallway. Your friend halfway through repeats your words loudly so that the person at the end hears them clearly. That's exactly what a repeater does in a network. And the next device is hub. A hub is basically a multi-port repeater. It connects multiple computers or network devices in a LAN and forwards data to all the connected devices. A hub operates at the physical layer. When one computer sends data, the hub simply copies the data and broadcasts it to all other connected devices regardless of the destination. This means all devices share the same collision domain, leading to data collisions and slower performance. There are different types of hubs like active hub, passive hub, and intelligent hub. Active hub as power supply cleans, boosts, and retransmit the signals. Passive hub simply passes signals without any amplification, whereas intelligent hub can monitor and manage traffic similar to a managed switch. A hub is like a loudspeaker in a classroom. When one student speaks, everyone hears it, even if it is not meant for them. The next thing we are going to talk about is bridge. A bridge operates at the data link layer. It connects two LAN segments and helps in filtering traffic based on MAC address. When a bridge receives the data, it reads the destination MAC address. If the destination device is on the same network segment, the bridge ignores the data. If it is on the other segment, the bridge forwards it. This reduces the unnecessary traffic and improves its performance. There are different types of bridges, like transparent bridge, which automatically learns MAC addresses and forwards the data to the correct segment. In this type of bridges, devices do not notice the presence of bridge. The other is source routing bridge, where the sending device specifies the path for the each frame and the bridge used to deliver it. The next device is switch. A switch is an advanced multi-port bridge that operates at the data link layer. It connects multiple devices and intelligently forwards data only to the correct destination instead of simply broadcasting to all the connected devices. A switch maintains a MAC address table to identify which device is connected to which port. When the switch receives the data, it checks the destination MAC address and forwards the data to the specific port. This reduces the collisions because each port forms its own collision domain. Even though both hub and switch are similar in working, a hub sends data to all devices on a network which can cause collisions. While a switch is smarter, it sends data only to the intended device, making the network faster and more efficient. A switch works like a post office clerk. Instead of sending every letter to everyone, it checks the address and deliver it only to the right person. Another important networking device is route. A router is a network device that operates at the network layer. It routes data packets between different networks based on IP addresses. Routers are used to connect LANs and WANs. They maintain a routing table that dynamically updates to determine the best path for sending packets. Unlike switches, routers divide both collision and broadcast domains, providing security and efficiency. They can also perform network address translation and can also act as firewalls. A router is like Google Maps for your data. It finds the fastest and most efficient path to reach the destination network. The last device that we are going to discuss is gateway. A gateway connects two networks that use different protocols. It can operate at any layer of the OSI model, but it usually functions at the higher layers. A gateway works as a protocol converter. It takes data from one network, translates it into a format that another network understands, and then forwards it to the network. These are basically used when two systems use different communication architectures, such as connecting a TCP IP network with an older mainframe system or some other network. Because of this translation function, gateways are more complex than switches and routers. That's it for today's video, guys. Thank you so much for watching. Let me know your thoughts and opinions in the comment section below. And if you find this useful and informative, don't forget to like, share it with your friends, and subscribe for more such videos. See you in the next video. Bye.